Okay, so solving equations is one of the most fundamental lessons that you're going to get in seventh grade because it's going to be used all the time in eighth grade. So solving for variables in equations is an absolutely necessary skill. So I broke it down into four major parts, and you're going to do these parts in this particular order in order to solve any equation. So there's four steps that I would say generally you're going to do in this order in order to come to a final solution of, say, x equals something, right? Or whatever variable you're looking for. So the first thing to do is to perform any distribution that is in a problem. So let's say that there was let's say it was 4x minus 2 times 4 minus 3x equals 12. So the first thing that you need to do is to distribute if there's anything to distribute. In this case, there is something to distribute. There's this -2, which is why I put this over here. Turn any subtraction into plus negatives. That should be part of this first step. Whenever you see a subtraction sign, make it into a plus negative. That reminds you that these are negative numbers that we're dealing with, so you don't forget their negativity. So that's a really important thing. That's the first step, okay? So I'm going to give you a chance to do just that. Do any distribution and turn any subtraction signs into plus negatives. Okay, once you have done that, and let's say I'll have distribute this out. So this is 4x plus -2 times 4 is going to be -8, plus -2 times -3x is positive 6x. All right, so now we're left with this. Oh, I'm off the camera here. All right, so we have done our distribution and we have turned our subtraction signs into plus negatives. The second thing that we're going to do, oh, by the way, sometimes there isn't distribution to do. So if there's no distribution to do, just skip to the second part, okay? So here's our second part. Our second part is called combining like terms. If you haven't already, turn all subtraction signs into plus negatives. When I talk about combining like terms, that means combining like terms on one side or the other of the equal sign. I'm actually gonna, let me change the problem here so there's more stuff to do. How about plus 2x minus 5, all right? 12 plus 2x minus 5, 2x minus 5. So when I talk about combining like terms, I'm talking about just combining the things on the left-hand side with other things on the left-hand side, or combining things on the right-hand side with other things on the right-hand side. We're not doing stuff across the equal sign quite yet. When I talk about combining like terms, we're only doing stuff on this side, on the left-hand side, with left-hand side terms, or things on the right-hand side with right-hand side terms. But we're not going back and forth across the equal sign quite yet. So I'll give you an example for you to do on just combining like terms. That's all we're doing, left on the left and right on the right. Okay, so why don't I combine like terms here? So the like terms to be combined here are, well, let me move this up here. So it's 4x plus -8 plus 6x equals 12 plus 2x minus 5. Okay, so let me just look at the left-hand side. Just looking at the left-hand side, I see that there's an 4x and a 6x. These are like terms, so I can combine them, okay? Forget the right-hand side of the equation. We're just looking at this like it were an expression. We're just looking at the left-hand side as if it were an expression just by itself. So if you were to have an expression with a 4x and a 6x, you would say, well, that combines to a 10x. And then this plus -8 can't be combined with anything because there's no other like terms here. Okay. Now when I combine things on the right-hand side, I'm just going to combine things that are like terms. First, let me make this minus 5 into a plus negative. Okay, so do you see that I can combine the 12 and the negative 5 into a positive 7? I combine those two. I can't combine the 2x because that is a different kind of term. This is what combining like terms means. Just on the right-hand side, just on the left-hand side, as if you're treating it as two expressions that are set equal. Okay? So I'll give you a chance to do another sort of combining like terms. Okay, now that we have done these two steps, now we're going to do the property of equality. So far we haven't done anything that is crossing the equal sign. Everything that we've done is on one side or the other. I'm just going to write this up here. Okay. Now, the property of equality, this is a vocabulary term. Property of equality means whatever you do to one side of the equation, you have to do to the other side of the equation. And what does that mean by doing something? That means if right now, we have a really nice, you could think of it as a seesaw. And I'm gonna write this, so this is on one side of the seesaw, and this is on the other side of the seesaw, and the fulcrum of the seesaw is in the middle. Okay, it's like a scale, all right? So right now these two scales are exactly the same. And so this is a very balanced scale, okay? So if I introduce something into the equation that isn't here already, see, combining like terms, we can combine like terms, and we don't need if I combined, two terms on the left-hand side, I don't need to do anything to the right-hand side because these terms on the left-hand side were already there. Okay, so I'm not introducing anything. But if I introduce something externally to either the left or the right-hand side, I need to introduce it externally to both of them. Okay, so here, if I were to add an 8 to this side, just out of the blue, I am adding something externally. I came up with, I have 8 over here, and I'm bringing it over here, okay? It wasn't in the equation before, but I'm adding an 8. So if I add an 8 to this side, I have to add an 8 to this side, okay, to keep it balanced. Now, why am I trying to add an 8? Because this is a negative 8. I want to get just x's on the left-hand side and just numbers on the right-hand side, so I can get x equals something. So I am going to do what we're calling an inverse operation. So the inverse of a negative is a positive. So if I add the positive equivalent, if I add the positive to the negative, they cancel out to 0. So that's why I'm going to add an 8 here. So this cancels out to 0. So now it's 10x by itself. And over here, 7 and 8 is 15. Okay? Now I'm going to do the same thing. Oh, just so you can see. Now I'm going to do the same thing with the x's. So right now, this is a balanced equation. So I'm going to now, let me write it up here, 10x equals 15 plus 2x. I'm going to subtract 2x from both sides. Now this is something that I'm externally putting onto this equation. So since I'm subtracting 2x from this side, to get rid of this 2x, I have to do it to this side as well. So I'm left with 8x equals 15. Okay? Now, 8 is being multiplied against x. This is 8 times x. So in order to get x completely by itself, I need to divide both sides by 8. So x equals 15 over 8. And that's a great answer. If you want, you can do 8 into 15 is 1 and 7/8. If you want, you could turn 7/8 into a decimal, but please just leave it as a fraction. Fractions are great. Okay? So we have done the property of equality. Whatever you do to one side, you do to the other. That's the property of equality. And we have isolated the variable, meaning the variable is completely by itself. Okay? So I'll talk more about isolating the variable in the next video, but I like to give you a couple chances to solve some equations using these 4 steps and this side step as well, okay?